My name is Duncan Shaw. The paper on which I will be speaking is called On the Structure of Atoms. I do not have any slides, so you will have to engage your imaginations to create the structures in your mind that I'm speaking about. The idea of atoms being structured by particles that are physically attached to each other, like connected pieces of a Meccano set, or like a Lego set, has been around a long time. As a broad proposition, it has a certain appeal. However, it is not in vogue at the present time. And perhaps the reason for this is that it is difficult to envision the precise details, such as how particles might be shaped and how they can combine together to form physical structures. Present-day science conceives that forces such as the strong force and electromagnetic forces provide atoms with structure. However, what if the force concept turns out to be wrong? Then the physical attachment approach, that is the subject of this paper, comes back into focus. This article of necessity relates to the structure of atoms. It proposes a concept of atomic structure based upon the underlying premise that the particles that constitute atoms are physically joined together. The proposed concept is that the atom is a mechanical structure in the sense that all of its particles are physically connected together. This concept encompasses the particles in the nucleus and the particles that occupy the volume that extends from the nucleus to the atom's outer perimeter. The particles, according to this concept, physically anchor each other such that when combined together, they form a solid structure, that structure being the atom. This proposition has many complications. If the concept is correct, it may eliminate the present generally accepted concept that the strong force is the means by which the constituent parts of the nucleus are held together. Another is that it may eliminate the concept that electromagnetic forces bind the constituent parts of the atom together. There are many implications to this overall concept, and I'll deal with those for a moment. It is suggested that atoms need to have solid structure. I use the word solid in the sense of the particles being firmly but flexibly held together so as to form a structure. The word structure is used in the mechanical sense, as in regard to a building or a bridge, where a stable structure is formed by its constituent parts being physically joined together. Why must atoms have solid structure? Well, let's look at that from the point of view initially of atoms in their solid state. That is, atoms that form the building structures, materials for a building. Without solidly structured atoms, I suggested it is fair to say that buildings would collapse. Indeed, I'd go one step further. You couldn't possibly construct a building unless you had solid atoms to work with. In regard to atoms in their other states, solidity again, or structure again, is important. Atoms contain immense energy, and they need to have a solid basis to contain that energy. At least that's my suggestion. The atoms, no matter whether they're in the solid state or liquid or gaseous state, are in constant collision with each other, whether it's by vibrations or actual collisions. They need to have something that allows them to withstand those collisions and not fall apart. Turning to implications, I mentioned one, the concept of the strong force that is said to bind the particles in the nucleus together. It is built upon the proposition that in order to break apart the constituent particles in the nucleus, it takes a great force to do it. Fine, an implication. But if the particles in the nucleus are actually mechanically connected to each other, it also seems to me to follow that if you're going to break them apart, you need a great deal of force to do so. So the implication is simply that instead of the so-called strong force that binds, it is the mechanics of connection, the physical connections that bind. Even looking at the rest of the atom, the electromagnetic forces that are said to keep the particles in their positions, such as the electrons. How about if there are no how about if electromagnetic forces, in fact, do not do that? If you have mechanical connections straight through the atom, you don't need electromagnetic forces. That is another implication of this suggestion. Electrons. It is said that electrons are in orbit. At least many scientists say that. Other scientists say there's a cloud of electrons that surrounds the nucleus. But let's stop and think about that for a moment. If an atom is to form a solid structure with other atoms so that they hang together, connect together, then there must be solid structure for them to attach to each other. And how can a cloud of electrons attach? I don't see it. It doesn't make sense to me. How can swirling planets swirling around the nucleus in that concept of the atom, how can you get the connection? Well, some say, well, it's electromagnetic forces. But here we're talking about the situation where those magical forces do not exist. So, picture it in your mind. You've got one atom here, and all around that atom there are swirling electrons. And you have a neighbor. All around there are swirling electrons. Try imagine how they physically join together. I suggest you can't do it unless you bring in so-called electromagnetic forces which are said somehow to do the job. Storage of energy. It's well known that atoms contain an immense amount of energy. Well, how can that energy be stored? How can it be stored in such a way that it doesn't break apart? The suggestion here is that if the atom is mechanically constructed, it can hang together and it can contain whatever is causing that energy. And that leads to the question, well, what does cause that energy? The only ways I can see in my mind are vibrations within the atom, or spin, or rotation of some sort, or vortices within the atom, another method of spin or rotation. Well, of those, what makes sense as being a way that the atom can store the energy without falling apart? Well, I suggest that vibrations is the main candidate. You look at spin, and you look at rotation, and you look at vortices, and none of those carry with them the idea of hanging together in a structural sense. Try visualizing a building that is constructed of stuff that has vortices or rotations or spin, and it's practically beyond imagination as to how the structural strength of that building can be maintained when the essence of the building materials are full of spin, vortices, or rotations. On the other hand, any building that we know of, this desk, any bridge, always has vibrations. And the vibrations go with physical connections. I'm talking about everyday common sense reasoning on it. So in this regard, I suggested one of the implications of this overall suggestion is that the main method of storage of energy within atoms is by way of vibrations. The shape of the particles. This is a tough one. This is probably one of the reasons why we always shy away from this. Or we find that, all right, you've got to go beneath, and there are always smaller particles so that we can sort of put off to one side, trying to visualize how it is that they hang together. We hear the expression gluons. Whatever gluons may be the Higgs particle is a gluon. But even if that sort of a particle does exist, it still begs the question, what is it that can give the atom structure? And if there is such a thing as a gluon, well, maybe it's a hammer and nails of some sort, but it's got to be, I suggest, in this particular approach, it's got to be something that can physically connect things together. Now, on the subject of the shape of particles, let's let our imaginations carry us where we will. I know where it's carried me in writing this paper. I visualize a sea. Well, if you've got fundamental particles that are shaped like a sea, one sea can hang on to another, can hang on to another. If they're shaped like an S, you've got the same thing. They can hook onto each other. And I'm searching for something that allows physical connection. I put this question to you all. Can you see any other ways that this might be accomplished? Once I'm through here, I propose to open the floor to see whether there are any other suggestions as to how this might be accomplished. Shells and other ways to keep particles within atoms in their positions. Let's take the area between the nucleus and the outer reaches of the atom. Well, with the cloud and orbital theories, you've got everything swirling around, and presumably that fills the space, but it doesn't answer the question as to how two atoms can hook together. So there must be another way, if this approach is correct. How can there be a structure? I mean, we think of the electrons and the amount of space or area that is occupied by one electron or by several electrons, depending on the atom, and ask yourself, does that come anywhere near close to filling up that space between the nucleus and the outer perimeters? Well, the answer's got to be no. But if the answer is no, then how can there be structure? Well, here I suggest, because I am working on the basis that there is structure, I suggest there must be a structure of some kind, but not necessarily the electrons. How about if there's something else that creates that structure? And here we've been talking about ether in one form or another, and I only use ether in the sense of there being something of in the nature, a particular nature, that is perforce smaller than the major particles that make up an atom. Well, shells, the possibility of shells. What would make up those shells? We can say, all right, there are shells that keep the various particles in their positions. But let's focus on the shells. What makes up those shells? And I'm talking here in terms of implications of this theory. So I suggest here that one possibility is that there are structures in atoms into which the various particles, as we know them at the present day, fit. Well, that's another area of food for thought. The outer reaches of an atom. If you got atom A and atom B, and together with atoms C, D, and E, they hook together and form a structure, in other words, the solid state, then surely the outer reaches of the atoms must somehow hook together. Might those shells that are made up of ether, or whatever one wishes to call that tiny particle, made up of C's or S's, as I've been describing them, might that form the outer shell? Does there need to be an outer shell? Well, I suggest if you want a solid, there does. And I suggest that if you wish that atom to be able to withstand collisions with other atoms, you do need that outer shell. Well, here again, another problem of implications of this particular approach. Basically, you have it. I don't suggest that this approach is right. I don't suggest it's wrong. But there's a lot being said at this conference about the idea that everything has a physical basis to it. And if everything has a physical basis to it, then gravity has a physical basis to it. Other things that we know of have physical bases to them. And in other words, the so-called idea of the four forces, for example, the main forces. Let's suppose that they don't exist in any sense other than there is a physical underlying basis for them. And if there is a physical underlying basis for them, then it seems to me that atoms do need to have structure, and structure substantially, as I've been describing it. There you have it. That's the suggestion of this paper. It is written for discussion purposes. It is written to see whether there are ideas out there that track the Meccano set, the Lego set proposition of the atom, which, as I pointed out at the beginning, has been around for a long time, but never detailed to the extent where the full implications of going that route are there. Just one last point. It's all well and fine to have C's that hook, or S's that hook, or some other method that hooks together. But what we have in this world is a complicated situation where human beings hang together, tables hang together, we've got gravity, we've got, at least I'm talking about it in the physical sense, we've got tiny fundamental particles that build and build and build and become more complicated as we look closer at the makeup of matter and the makeup of what matter is allowed to be created on Earth and probably elsewhere as well. So, thank you for your attention. I'm open to questions. Yes?
Yes, sir. I am very excited by your submission because it tallies more or less with what we have been doing somewhere. I like your statement to the effect that everything has a physical explanation. If I may add, physical explanation and experimental verification. I absolutely agree with you that the atom must have a structure. The structure which can explain some of the observed phenomena, like the spectrum of emission.
Like
the spectrum of light emission, say from the hydrogen atom, the Balmer-Rydberg formula. The structure should be able to explain the emission spectrum of the atoms as theoretically derived by vogue. So while the structure is there, it must conform with the observations. There are a lot of observations regarding the spectrum of the hydrogen atom in particular. In this structure, you talk of electrons. Did you mention positrons?
No, I did not mention positrons.
They don't feature.
We're into another debate altogether, and I've not raised the question of positive and negative charges, for example, and whether positive and negative charges even exist, or whether there's a physical explanation for example, the more vigorous vibrations moving its energy toward areas where they're less vigorous, and we get a plus and minus. I simply don't know, so I can't meet that.
The atom is a neutral body, and therefore it must be composed of a balance of positive and negative charges.
But that's a generally accepted science. I don't necessarily agree with that.
Okay.
But
have you made any difference, say for example, between the atoms of an element in the solid form, the liquid form, and in the gaseous state? Any difference?
yes, for example, you can't build this table with atoms in the liquid form. But the liquid form does have an element of hanging together, and as distinct from the gaseous form.
Yes.
So I've made the assumption that the outer reaches of atoms in the liquid form do come into contact, but and have partial connections with their brother and sister atoms, but not the tight bond of connection that is required for the solid state.
Yes. So in other words, there is some difference
Oh, yes.
between the atoms in the various states.
Yes.
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 And we did some work along the lines we have talked about, and we arrived at other suggestions that may give a structure
Yep.
explaining the experimental observations. I would be glad if you give me your
I missed your words. Explaining the
experimental observations
vibration.
of radiation from atoms.
Yeah. Okay.
I'll be too glad to send you a paper on this if you give me your email address.
We're talking radiation or vibrations.
Radiation.
Radiation. Yeah. All right.
I said we have done some work on this,
Okay.
and I'll be glad to send you a paper
Yeah.
along the lines.
You know,
With some difference.
boy, I would be surprised.
If you give me your email address, I will send you a copy.
Okay. You will send me a copy of your paper?
Yes.
Oh, good. Thank you.
Give me your email address. We
As
are along the same line.
a matter of fact,
It's here.
it is.
Okay, I will send it.
And it's in there. It's the
Yes,
top of
okay,
the
okay,
article
it is,
itself.
it is. I will send it.
Yeah.
Thank you very much. It's very exciting.
Right. Thank you.
Yes.
I have some general comments. I do think that physics should at least accept as a high probability that Rutherford's scattering was meaningful, and that when you can send a helium atom or a helium nucleus through a tin foil, and it usually doesn't hit anything, that I think we all agree that what we see is, what we see and feel as solid matter is mostly empty. Now that doesn't mean there can't be thin spokes or something, but part of what is I think part of what's bothering you is what bothered the first and maybe the finest Greek scientists, in that is they would not accept that there was not continuity in this world. They insisted that it was that things be continuous. Now, I might say you may have a continuous gauze like a sponge, with a lot of holes in it, in classical times, the vortex sponge was used to model almost everything, even though it was mostly empty. But at least they probably felt they had some degree of continuity, even though it was mostly empty. It seems to me, if I had to grab something that might be a good candidate for explaining a lot of things, it would be Planck's constant. Now, we heard someone say that Planck's constant, that there might be a lot of variables there, that certainly frequency of light can vary from just about infinitely small, maybe a Planck's wavelength or something, all the way to at least so long away that things were pretty cold and like cosmic background radiation. In other words, at first when we look at Planck's constant, we see a lot of variation, but if we express it as angular momentum, I do think that it's constant, and that constant means something. For example, many different nuclei and atoms, I think, spin at, say, 1/2 something called Planck's bar constant, or maybe it goes from 1/2 to 1, or 1 to 2, or sometimes 3/2, but they're nice multiples of one another. And if we do see Planck's constant as something spinning, then we begin to think of shape, and once you get a round shape, or even a spherical shape, you can pile things up and make fancy crystals. We've all seen, the diamond is one type of crystal, and there's more different types of packing than I can make, that I can name, as you put ping pong balls, So those, I guess, are my general thoughts. I just think the Greeks considered a sphere to be, I guess, the perfect form because, I don't know why, but probably because everything could be expressed as equal, distance from a point or a radius. And probably waves also have an aspect about them, spherical waves, that makes it a nice candidate to accomplish many things. That's all.
Okay, well, thank you. I don't think anything I was suggesting runs counter to Planck's constant. And indeed, if there are fundamental particles, and that's what this is really all about, is there a fundamental particle that can hook onto its neighbor and on and build what we have? I don't know the answer to it, but I think it's a question worth raising. Now, ether cells. In other papers, I address the question of ether cells. Well, let's assume that an ether cell is a conglomeration of fundamental particles that are hooked onto each other. And they form a cell. And they form a cell that is flexible. They form a cell that can hook onto other ether cells because of the nature of the material from which they are made, the fundamental particle from which they are made. They can bump into each other. They can have a certain length or average length that they would go when they bump into other ether cells. They can be the basis of quantization because they can vibrate. There are many things that can flow from it, and I don't think any of that runs counter to what you have been saying. You did suggest that the Greeks had an idea that the sphere is the perfect form. Well, I think that does run counter to what I'm suggesting because I do not see how a sphere can attach to a sphere unless its borders are such that there are particles that can hang on to each other. Because otherwise the sphere is going to bounce off the sphere. And as we know, attachments in some form or other are what allow us to have matter. And I say matter in the sense of atomic matter. Now, whether the attachments are because of electromagnetic forces or whether they're physical, I don't know.
If they are oppositely charged, they will stick.
Well, then you're onto the question of charge. What is a charge? And I've checked every text I could find, and all the authors talk about a charge in terms, not in terms of what it physically is, but in what terms of what it physically does? How do you measure it? And I still can't find anywhere a physical definition that creates a picture in my mind of what a positive charge is and what a negative charge is. And when I came to that conclusion, that's when my mind started to ask, is there such a thing? Well, of course, when you ask yourself, is there such a thing? Well, if there is not, then what can explain the various phenomena with which we are familiar? And that's where my mind started to wander into, is there a gap in a structure in the atom that is filled by a certain particle being pushed into that particular area? Is that partly positive and negative? Is it a question of flow, of the type of flow that E.N.L. Dinu was demonstrating? You'll note he was just using spinning objects. He wasn't using any positive and negative, but he was getting positive and negative effect. Is that an explanation for positive and negative? Is the explanation that the more vigorous moves towards the less vigorous? As we well know, as heat will move from the heated area to the colder area. Is that positive and negative, or is that just something we choose to call positive and negative? That I don't know, but you raise that, and my answer is that I have real doubts that the idea of carrying a positive charge and carrying a negative charge have any reality at all. Any other questions?
I just might add that
Oh, yeah.
I think, I'm sorry, I didn't want to interrupt, Democritus, who came up with his atoms,
Yeah.
he never gave a good explanation as to why he was willing to accept fundamentally sharp atoms that cause sharp objects and nice spherical atoms that caused this feeling of smoothness. But he had a very large system where each atom was just fundamentally, automatically the way it was, and it would, I don't think it would change. And so that I think that some of his atoms actually had hooks, or was a little bit like Velcro, so, and of course, as I was saying earlier, a person like Francis Bacon, he felt some of those dilemmas that you have outlined, I think, and he said, like some others, why don't we try to give up trying to absolutely prove the way things are and just try to investigate them to find out how they seem to be. It isn't a perfect solution, but I think you're barking up a difficult road.
Oh, there's no question. I'm barking up a very difficult road. But the Copenhagen Convention, and basically what you're saying right now, it's a tough problem. We've come a long ways, and we've got the concept of field and so on. That we've got the quantum mechanics, and we can do a lot with those tools. But we've also got curiosity, and curiosity certainly pushes me beyond those tools, and it causes me to ask questions like this. I'm not expecting a nodding of heads in approval of what I've raised, but at the same time, I think I've raised a legitimate question. And I can't say much more than that. Does anybody have any thoughts on what may constitute the Velcro? Because I think you've raised a good point, because the kind of particles that I have in mind are not too far off from Velcro, because the C can hook onto a C, the S can hook onto an S. I search in my mind for other ways to hook onto each other, and apart from so-called electromagnetic forces, I haven't found anything. And so it remains with me a question of simply human curiosity. Right? I think, unless there are any more questions, that does it. Thank you.